Good morning, everyone. For our final lesson in trigonometry, we're going to talk a little bit about applications. Okay, although we have done some word problems along the way, so we're not going to get too deep into that. But the two things we're going to talk about is one, I mentioned yesterday, we're going to kind of review how to decide which rule you're supposed to be using, because we've reviewed SOHCAHTOA, we reviewed sine law, we reviewed cosine law. So just making sure you have the idea of when I look at a triangle and I'm not sure, how do I pick which one it is? And in the application we're going to briefly talk about is bearings. So if, say, you were hoping to go to Jordan College for marine navigation, this is something you might end up talking about there. So navigation is an application of trig, and I'll show you a little bit about how to set up one of those problems. Okay, so this first part is just a list. So just to recap, here are the different things we've learned about or reviewed. Okay, so the first thing that came up, and that was all back in the measurement unit, was Pythagorean theorem, but that is a method for solving for information in a right-angled triangle. Okay, also we never really called it this, but the angle sum triangle theorem, just the idea that the angles add 180 degrees in a triangle. Okay, that's something that we use in the process of solving triangles. We reviewed our trig ratios, so SOHCAHTOA, right? Sine is opposite over hypotenuse and so on. So make sure you got that. Okay. We spent a couple days on sine law, right? We reviewed the sine law, and then we talked about the ambiguous case, that there are some situations where sine law gives more than one answer, and you might have to consider checking more than one answer. Okay, and finally we reviewed the cosine law and how to solve for sides and angles with that. So the first part of this is just going to be trying to identify, okay, what rule do you think it is? So on the next slide, I'm going to put up a few triangles, and I'm going to ask that the video be paused for a couple minutes and just try to decide what rule it is you're going to use to solve for x in each diagram. You don't actually have to solve, okay, but just what rule do you think you would have to use? Okay. So I'll see if I can get to fit these all at once. Okay, well, there's the first four. So then you pause the video right now for like 2 minutes and have everyone discuss with their neighbor what rules do you think you need for each triangle. Okay, so hopefully you're back now, and we'll just kind of discuss. So for the first one in the top left, okay, it's a right angle triangle. So that means we use either Pythagorean theorem or SOHCAHTOA. And because it's the angle we're looking for, this would be a perfect one for SOHCAHTOA. Although I'm realizing right now that I kind of need to have another side length, don't I? So maybe if I also knew this one. Okay, I need two sides and I want the angle, I can figure it out with SOHCAHTOA. Okay, for the top right, okay, I've got three sides, and I'm missing an angle. So we covered this case yesterday. This one is cosine law. All right, I don't know if I have a right angle in there or not. Okay, so I have to use cosine law. Okay, for my third triangle, okay, key thing is here I have some pairs, right? I have this side and that angle. I know the pair, and here's the one I want, and I have the side across from it. So because I can make those two pairs, this is going to be a sine law problem. Okay, for the fourth one, I have a right angle triangle. I know two sides, I need the third one. Okay, this is going all the way back to Pythagorean theorem. I'm not going to write the whole thing out there, okay, but that's what it is. Okay, so here comes two more. So again, may pause the video for a minute, okay, and discuss what do you think the rule would be. Right, so again, you're back. So this one on the left, okay, I have two sides and the angle between them. That looks a lot like the ones we were doing yesterday. So this one is cosine law. Okay, for the other one, okay, again, I have some pairs, right? I have a side, an angle, and a side that I want. Okay, now I don't really directly have what I need, okay, but it wouldn't be too hard to get it. Let's back up a second here. Okay, I know two of the angles in the triangle, so it would be pretty fast to get the third one, 25, and now I can check this out. Okay, so this one is sine law. A little bit of work to set it up. We also have to use the fact that the angles add to 180. Okay, but it will be a sine law problem to solve that. Okay, so in summary, okay, in the right angle triangles, we're definitely going to use SOHCAHTOA and Pythagorean theorem. Now, there's nothing to stop you from using sine law or cosine law because they work in all triangles, but both SOHCAHTOA ratios and Pythagorean theorem are simpler to use. So you're saving yourself a bit of work if you recognize it's a right angle triangle and use one of those. Okay. Okay. If it's not a right angle triangle, then it's going to depend on what information we have. Okay. So, so for instance, we had that case where I knew the sides, right? If I know all the sides, and I want to find an angle, so all sides are known, need angle. Okay, this one is going to be cosine law. Okay, the other case for cosine law is when I know two of the sides, okay, and I have the angle in between them. So let's say that was like say 65. Okay, and I'm looking for the other side. So if we know two sides and the angle in between, this one is also cosine law. Okay. For the other cases, so for example, I know an angle, okay, and I know two of the sides, okay, but it's not contained between the two sides, it's some other one. Okay, that is going to be sine law. Okay. This one is two sides. Angle is not between. Okay, so something like that. Okay, in the last case, same kind of idea. And this is where the ambiguous case can come up. Sorry, that was the previous one. The last case is I've got the two angles. Okay, and I want to know another side, then it's going to be sine law. Okay, and even if I quote have the wrong angle, like if I move this one up here, again, I can just use the fact that the angle's at 180 to get the other side. Okay, so again, that's going to be a brief summary and guideline of how to decide which triangle is which. Again, the big thing would be practice. The more you answer the problems, okay, then the more likely you'll be able to pick up on what type of situation it is. Okay. So the other thing I want to talk about with you, okay, and this is the part that has to do with bearings, okay, is typical navigation bearing is what's called a quadrant bearing. Okay. So the way these are written out is that you have an angle between 0 and 90 and usually start from north-south. Okay. So for example, a bearing might look like north, let's say 50 degrees west. So that means from the north line, right, north, east, south, west, okay, that I'm going to go 50 degrees towards west, okay, and that's where my direction is. Okay, if I tried something like, south 20 degrees east, okay, it might look something like this, because that's 20 degrees off of south. Okay, so that's all it is you have your starting direction, which is typically going to be north-south, then how many degrees towards east or how many degrees towards west. Okay, that's how we write them out. When we're solving navigation problems, often we have to draw a couple of these bearings, and then we'll get a triangle, and we'll be able to use that our knowledge of trigonometry to solve for something in that triangle. So I'm just going to show you one example of how that would look. So here's our example. A boat leaves port, okay, and it travels 25 knots, bearing south 75 east. It changes course to south 15 degrees west and travels 14 knots. An emergency arises and the boat must head directly back to port. How far must it travel to get back and in what direction? So, okay, helpful here to draw a grid. Pardon me. Okay. So let's just plot out the different things that we see here. Okay, so initially goes south 75 degrees east. So 75 degrees east is quite a ways this way. That might be 75. Okay, and we're going 25 knots that way. Okay, so this side is 25. Okay, changes course to south 15 west. So what we do, we go to the end, right, where the boat stopped. And I'm just going to draw another little grid there. It's going to be a lot smaller. Okay, and now I'm going to visualize the other one, south 15 west. So that would be just a little bit off of south, so maybe something like this. Okay. How far must it travel to get back and in what direction? So we'll pencil that in, right? From the end, this would be the way back to where the boat started. Okay. And now I've drawn my little triangle, okay, and we'll try to get some information in there to figure out what's going on. Actually, I'm just going to redraw this a little nicer beside it. So the triangle looks like this. Okay. So now I got to start filling some things in. Okay, what's potentially the tricky part here is getting the angles in. Okay. So the 1st one to note, okay, let's see, back up here. put my side lengths on. So this one was 25 up here, and this one is 14 here. Okay, so let's try to fill in some angles. I'm going to add on my little grid lines again. So there was that corner. And there was this corner up here. Okay. What I got from the question, that this little angle in here was 15 degrees. So that means this one beside it, okay, going all the way the rest up to west there, okay, that has to be 90 minus 15. Okay, so that's 75, because that corner makes a right angle. So the little one's 15, the leftover part is 75. Okay. For the other corner, okay, this is going back to like your grade 9 for a second. We said this angle up here was 75, okay, because it was the whole south 75 east. Okay, that means, if I draw this on here, this might look a little familiar. Okay, that's the Z pattern. Okay, that means that this angle over here is also 75 degrees, okay, which means that the angle inside here, again, is 90 take away 75, or 15 degrees in that corner. Okay, so if I start labeling the points on my triangle, so A and B and C, okay, the total of the angle in that corner, B, so all the way from here to here, I have 15 plus 75, so it's actually a 90-degree angle in that corner. Okay. So now I can use this to figure out what's going on over on this side. Okay, because that's the distance the boat has to travel to get back. So actually we got kind of lucky here. We have 90 degrees, so that means I can just use Pythagorean theorem to solve for that missing side length. Okay, now the letters are going to look like they're kind of out of order for a second here, but we'll start writing it down. Pythagorean theorem is a squared plus b squared equals c squared. However, the way I've labeled my triangle, b is actually the hypotenuse. So let's change that up. So a squared plus c squared equals b squared. Okay, we'll start filling it in. So our A was 14, our C is 25, and we're looking for B. Okay, so 196 plus 225 is B squared. Okay. 421 is B squared, which means side B is about 20.5. That's not right. I hope some of you caught that already. That's my mistake. 25 squared is 625, not 225. So that's 821. And so that is about 28.7. Okay. So the distance back to the starting point is 28.7 knots. Okay. Now I'd like to know what direction the boat has to travel. So I'm going to go down to the bottom here. Okay, we've got to find the angle in the bottom corner right there. Okay, so that's angle C. And again, this is a right angle triangle. And my diagram up there is very messy. But maybe I'll try to draw that out one more time down here. Right, so this is the triangle we ended up with. So we have 28.7. This one was 25. This one was 14. And we learned this was a right angle. Okay. So the angle in the corner, I'm looking for angle C at the bottom because this is where the boat's traveling from, is down here. Okay. So I can just use something from SOHCAHTOA. I have all my sides, so it doesn't really matter. Let's see, we're going to use sine. So this would be our hypotenuse. This would be my opposite. Okay, so sine of my angle is opposite over hypotenuse. So we have 25 over 28.7. Okay, so if we do our sine inverse, we get about, rounding it off, 61 degrees. Okay, so 61 degrees in that corner. Okay, to actually get the numbers I need, okay, because again, we want this to be in a bearing. So I'm going to go down here. Okay, so same idea as before. The total angle is 61. I knew that this little angle in here was 15. Okay, using the Z pattern again, the little angle in there is also 15. And I apologize for this very messy diagram. Okay, so the leftover bit would be, which is what I want, this one over here. This is 61 minus 15, which is 46 degrees. Okay, heading from north towards west. So after all that, my final answer is therefore the boat must travel 28.7 knots bearing north 46 degrees west. Okay, so there's a navigation problem solved with trigonometry. I appreciate your patience. That was quite a bit of stuff in one example. Thanks for watching. For the rest of the class, either you should be working on this practice work right here, okay, or of course, I'm sure some of you will choose to work on your assignment instead, which is due on Tuesday next week. All right. So thanks again, and I'll see you tomorrow.